Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nurafis. I will present a calculation manual for group assignment. So, firstly, I'm going to show our circuit that our group has discussed, which is have two resistant, one capacitant, and one inductor. So this is our information that we get, information for this circuit. So we goes for the finding VT, which is this one. So we're using this signal processing. So from this we use a general equation for Fourier series, and for the function we got from the graph, which is from 0 to 1 equal to 2, and 1 to 2 equal to 0. So we also know that the period for this graph is 2. So we goes for the A naught. We use the formula of A naught and insert all information that we have, which is the function and the period. So we got 1 for A naught, and for A n we use the A n formula and insert all the information and solve it, and the result we got 0. A n equal to 0. For B n we use the B n formula and insert the information that we have. Until this, we must know what value that we got, what result it is from odd or even. So for the odd we got negative 6 over n pi, and for even we got negative 1 over n pi. So from the result that we have, we insert the value for A naught, A n, and B n. So as we know, A n is 0, so A naught is 1. And for B n, we use for 3 terms: term 1, term 2, and term 3. So this is the general equation for the VT. Okay, so for the circuit analysis, for the manual calculation, first we gonna find the amplitude phase form for the general equation that we got last time. So the last time we got this kind of equation. So from that we can know that an by using formula square root an squared plus bn squared. So we got this same, and for the degree, for A1 we use the formula tangent negative 1 bn over an. So we all know that an equal to 0, but we use the an, the equation before the an, so we get the degree for the A1. Same goes to for A2 and A3. But for A2 we use the equation for even, because 2 is even. Same as the degree, we use the same formula. So we got the N1 voltage, N2 voltage, and N3 voltage. So we goes for the impedance. From the circuit we know that there are 4 variables, which is resistant, 2 resistant, 1 capacitors, and 1 inductor. So we need to find the total. So from this we solve by using we solve to 1 resistor connected series with the inductor and capacitor. So we solve, we got this. And for the overall total for impedance, we need to plus with the one more resistance. So we got this. To get the voltage output, we need to use the voltage divider. So we insert what we have what we have gained from the previous calculation, which is and insert into the formula of voltage divider, and solve the Z over Z total before we insert the Vs, after we get the easiest form. So next, for to finding the each of the form voltage output, after we gain the easiest form of voltage output, now we insert all the information for the voltage source that we have calculated previously. So we get the answer for voltage output for N1. So next, we calculate for voltage output for V2. Same goes for the voltage 1. We insert all the information, but for V source, we use the V source for V2 that we have calculated also. And same goes for the V3. We use the same method, and the V source is for the V source for N3. So after the three terms calculation, we can conclude the calculation in one form, like this. But this is actually a typo. This is V output actually for this circuit. So for current, after we get the voltage output, now we can get the current by using Ohm's law formula, which is I equal to V over Z. But we can determine the I by using V over R for R equal to 100 in the circuit. So for the N equal to 1, we use the voltage output that we calculated, divide by 100, then we get the answer. Same goes for the N2 and N3. We use the different voltage for we use each of voltage output that they gain for N2, voltage output for N2, and for N3 we use the voltage output for N3. So after we calculated all the current output, we can conclude all the calculation in one form. So this is the form that we get from the calculation. So for the power, we use the formula of power, which is VDC multiple IDC plus Vn multiple In divided by 2 cos phi n theta n minus phi n. So which is this? This is voltage degree, and this is current degree. So we insert all the information that we get. As we know from the general equation, VDC is 1, and multiple with IDC also 1. So we insert also all the for AC analysis. So and we get the scalar quantity for power.
So next we continue to the simulation. For the circuit, we use the circuit that we sketched before, which is this. And for the signal processing, we use VST that we get from the manual calculation. Then we look at the circuit. For the circuit, we have the control voltage source, which will give the power supply for pulse signal. Then we have R1, L1 and C1, and R2 that as VO. So for this circuit, we have about 2 resistor, 1 inductor and 1 capacitor. Then we have a 3 voltmeter that show the voltage for each branch, and we also have the ammeter to show each branch current. Then we have the wattmeter to show the watt of the circuit. Next we look to the voltmeter. So for V1 we get about 2 volt, which exactly same as we get in manual calculation. Then we continue to V2, and as we look in here, the result are about 0.08 to the 0 volt. As a manual calculation, we get around 0.31. So at this area, we can see the result are nearly same as next we look to V3. For V3 we get this graph, and the result are nearly same as the manual calculation. And next we continue to the ammeter. For ammeter we get around 0.04 for the I1, which the result are also same as the manual calculation. Next we look I2. At the I2 we get around 0.03 as we see the graph. Next we continue to the I3. At the I3 we get this graph, and the result are about the same as the manual calculation. And for the last we go to the wattmeter. In the wattmeter we get the watt of the circuit is 0.5 watt. So the result are same as we get in manual calculation. So for the conclusion, I can say that the simulation and the manual calculation result are nearly same. So that's all from me. Thank you and